Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be a continuation of my long video format topic, Trigonometry, and this is now lesson number 24. For this morning, I will be giving example problems on the so-called values of the other functions involving a right triangle. The next time around, I will be discussing the continuation of this. That is solving trigonometric identities and proving trigonometric identities. But for this morning, I will be giving you example problems on how to compute for the other functions if one function is given. Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 24. And the title of the topic will be example problems on trigo functions, meaning if we are given one function in any right triangle and the problem is asking for the values of the other functions because there are 6 trigonometric functions, right? So if we are given one, the problem is just asking for the value of the other 5 functions. Okay, I think these two examples is more than good enough to illustrate the concept on how to solve the other 5 functions. Okay, let's proceed. Example number 1. Find the remaining 5 function values by sketching if the value of sine of alpha is 2/3. Sine of alpha is 2/3. So the problem is asking what will be the value if the value of sine of alpha is 2/3. What will be cosine of alpha, tangent of alpha, cotangent of alpha, cosecant of alpha, and secant of alpha? The value of the 5 other functions. Okay, let's proceed with the solution. The figure will be this one. We are given a right triangle as always. So from the given value, sine of alpha is 2/3, meaning it seems we are given a right triangle. This should be alpha. And according to the problem, the value of sine of alpha is 2/3. By definition, sine of alpha is actually opposite over hypotenuse, considering alpha. If we try to consider alpha, because if we try to consider this angle, this is not opposite. Okay. So for the meantime, we'll just concentrate on alpha. This is alpha, so will be opposite. This is hypotenuse. And as per definition of a sine function, it should be opposite over hypotenuse. So it seems we are given the hypotenuse in the opposite side. And the problem is asking what will be cosine, tangent, secant, cosecant, and cotangent of alpha. Okay, let's try to bring out the solution. We are given the opposite, we are given the hypotenuse, so we could compute for the adjacent side. Pythagoras principle. The square of the hypotenuse should be equal to the sum of the squares of the two legs, the opposite plus adjacent, which is x quantity square. We represent the unknown adjacent side to be x. So this is x quantity square plus 2 quantity square. Solving for x, it will be the square of this minus the square of this, then we'll take the square root. So x is actually the square root of 3 square, which is 9, minus 2 square, which is 4, and x should be square root of 5. Okay, so we now know the value of x to be square root of 5. So the problem is asking what will be cosine. That's an easy one now. Because cosine will be adjacent over hypotenuse. Cosine of alpha will be adjacent over hypotenuse. It will be the computed value of x over 3. So they should be square root of 5 over 3. That's the value of cosine of alpha, our answer. For tangent of alpha, by definition, tangent of any acute angle is actually opposite over adjacent. It is 2. The opposite is 2. The adjacent as per computation is x. So tangent of alpha will be 2 over x, which is square root of 5. So that will be the value of tangent of alpha, and that will be our answer. For secant, if we try to bring out the definition of secant, it should be hypotenuse over adjacent. So it will be 3 over x. So this is 3 over square root of 5. That is secant of alpha, and that will be our answer. For cosecant, as per definition, it is hypotenuse over opposite. So this is 3. The opposite side is actually given to be 2. So this is 2. Right? So cosecant of alpha is actually 3 halves, and that will be our answer. For cotangent of alpha, cotangent is actually adjacent, okay, over opposite. So it will be x over opposite. So it's square root of 5 over 2. That will be the cotangent of alpha. Okay, so that will be our answer. In here, we could verify if this is correct, because secant is the reciprocal of cosine. This is actually 1 over cosine, right? And what is cosine? 1 over square root of 5 over 3. So this is actually 3 over the square root of 5. Same as this one. Okay? For cosecant, it is the reciprocal of sine. And what is sine? A reciprocal of sine is actually 1 over sine. Sine of alpha. I think we are given sine of alpha, right? So this is 1 over 2/3. Or this will be 1 over 1 times 3 over 2. Or that will be 3 halves. 3 halves. Cosecant. And for cotangent, the other solution of this one will be, cotangent is the reciprocal of tangent, right? Am I still on camera? So this is 1 over tangent of alpha. And this is 1 over, what is tangent? 2 over the square root of 5. So if we try to simplify this one, square root of 5 will go up over 2. Okay, this is same as this one. So the values now, I will repeat it. Cosine will be square root of 5 over 3. Tangent is 2 over square root of 5. We brought out 2 solutions. Secant is 3 over square root of 5. We brought out 2 solutions. Cosecant is 3 halves. We brought out 2 solutions. And cotangent is actually square root of 5 over 2. We brought out 2 solutions. Okay, it's an easy one. And the procedure is always like this. If you are solving a Trigo function and one function is given and the problem is asking for the other 5 functions, the solution will always be like this. Okay, example number 2. If the value of tangent of alpha is equal to 1, find the other 5 function values. Solution. Okay. Tangent of alpha is 1. So this should be 1. This 1. So the hypotenuse will be the square of 1 plus the square root of 1, then take the square root of that will be square root of 2. So the hypotenuse will be square root of 2. Right? For sine, it will be hypotenuse, For sine, it will be opposite over hypotenuse. So this is 1 over x. This is 1 over square root of 2. That will be our answer. For cosine, it is adjacent over hypotenuse. So it's still the 1 over square root of 2. Okay? And that will be our answer for cosine of alpha. For cosecant, it will be hypotenuse over opposite. X over 1, or this should be square root of 2 over 1, or that will be square root of 2. That's the value of cosecant. For the value of secant, it's the hypotenuse over adjacent, and it will be square root of 2 over 1, or that will be square root of 2. For secant of alpha, okay, will be square root of 2, secant of alpha. That will be our answer. For cotangent, it's either we could go back to the figure or we'll just take the reciprocal of tangent. Cotangent of alpha is 1 over tangent of alpha. This is 1, tangent of alpha is 1, so 1 over 1 will be 1. So cotangent of alpha will be equal to 1. That's it. It's as easy as that one. So for tonight, I have given you already example problems on how to compute for the other functions if we are given one function in any right triangle. Okay, good morning from Los Angeles. Professor David J.